In this session, we will try to uncover access specifiers and constructors. What are access specifiers? To provide security for the variables or methods, we have four types of access specifiers. First one is public. Second one is default. Third one is private. Fourth one is protected. By the end of the object-oriented programming concepts, you'll get the clarity, but for now, I'll explain this in simple terms. For example, I have a neighborhood here, and I have some houses inside the neighborhood. And here I have one big building with 3 floors, and it also has a compound wall around it. So this is a neighborhood, and this is a road. So let's assume there is a tap, water tap here. So who all can take water from here? The people who are in the neighborhood, and also the people who are on the road who are not belong to this neighborhood. So that is public from anywhere we can access it. So for example, let's say if I have another tap inside this neighborhood, who all can access? The people from the road cannot access inside this neighborhood. Obviously, the people who are inside the neighborhood can access the water from this tap. That is basically default. Access from current environment. Now let's suppose I have another tap inside this house. Who all can access the water from this tap? Only the people from this house. No other people can access inside the house of another person. So that is essentially private only within the class. The house is, say, for example, class. Now let's say I have different families renting out here in this building in the 3 floors. one, two, three families are renting out here, and I have another tap inside this. So who all can access? These are all the people who are dependent in this building. So these people can access this tap. So that is basically protected. So only within the class and its dependent classes. We will explore each of these as we progress, but that's a real world example to demonstrate these access specifiers. Now let's move on. Say, for example, adding variables into the class. How do we add variables into a class? We have seen this, but we can declare a variable into the class, just like normal variable declaration. I have seen this so many times, but let me demonstrate using example. For example, let's say I have a class called demo, and I have the main class, which is test. So inside demo, I'll declare variable like integer a, then double b, then char c, then boolean d, then string e, then I'll take the object itself demo. So if I have to access these variables, I need to create an object for demo. We will uncover as we progress, but this is how we declare an object. And if I have to access those variables, I'll use system out println and obj dot a. And I'll do the same for rest of the variables. Obj dot b, c, e, e, and f. If you see, we have not initiated the values for each of these variables. So if we print, we should get the defaults, which we have already covered. Default value of integer is 0. Default value for a double is 0.0. For character, it's just empty character. For Boolean, it's going to be false. For string, it's going to be null. And for object, it's going to be null again. But let's try to execute and print this Java C test dot Java, compile Java test execute. So we get 0, 0.0, empty string, false, and null. So now let's see how to add methods into a class. It is also just like adding variable to the class, but it has some syntax. So methods follow below syntax. It could have a return type, then name of the method, and if there are any arguments, or we can also call it as parameters, and then some lines of code. And it should return value, and then the method. So let's look one simple example how to define a method. For example, I have int a is equal to 10, comma b is equal to 20. And I'm defining a method void. Void, if the return type, there is no return type, then I'll use add as the method name, which is basically adds the integers, system out, println, say for example, addition plus a plus b. Then the method. And then inside the main method, main class and main method, we call the demo object using demo object new demo. And then we just need to call object dot add method. So let's execute this, compile, execute. 10 plus 20 is 30. That's the result. Now let's move on and look at setter and getter methods. So what are setter and getter methods? As the name suggests, setter methods are used to set the values for variables. And getter methods are used to get the values of variables. Let's see some examples so we get the clarity on how these methods work. For example, I have a string, say the name, and I'll write the setter method here. Void set name, and I'll take the string argument and say a, open, then name is equal to a, I'm setting it as name is equal to a. Now let's implement a getter method here. For getter method, I need I need a return type because I need to get the value which is string, and the name of the method is get name, and I'll use the return, and I need to return the name here. Those. This is how setter and get methods are defined. Then in our actual class and main method, I'll use student s1 is equal to new. Let me rename this class as student. So new student, creating another object s2 as new student. So I'll set a name here, set name for s1 student AAA, and for s2 BBB, and try to get the names printed up, system out, println. How do we get it using get name? This is for student 1, this is for student 2. So let me execute this, compile, and execute. We have AAA and BB. Now let's move on to the object creation process. So what is an object? It is a real world entity. It is used to access the data from the class, and it is used to store the data for temporary purpose. So what is the syntax? We have to write the class name, then object name, and new class name. We have seen in the examples just before this. And we can also write it something like class name and reference. So when we use the new keyword, a physical memory will be created. For reference, it's just gonna have the name, no permanent memory. So what happens when a new object gets created? JVM will assign a unique number for that object. We can get that number using the function called hashcode. For any object. So what is hashcode? Hashcode is, or maybe hashcode returns integer representation of object. Let's see some examples so we get the clarity on how it looks like. For example, if I have a class A and I'll just remove everything, just empty class, and I'll create a object A1 is equal to new A. I'll create A2 and also A3. So we created three objects, A1, A2, and A3. So let's try to print the hash code for each of these objects. System out ln A1 dot hash code, then A2 dot hash code, and then A3 dot hash code. Let's try to compile and execute. So these are the hash code values for A1, A2, A3. Say, for example, if I wanted to know the name also, then I can use A1 toString, A2 toString, A3 toString. Let me compile again and execute. This time I got name at the rate, and this is the hexadecimal representation of this numeric value. Get results. So the purpose of, say, setar methods is to set the values, and for getter, get the values. But if we have to implement the real business logic, we can use normal methods. Also, if we have, for example, say 5 attributes or variables, we need to have 5 setar methods to set the variables for these attributes, set the values for these attributes. For example, if I have 1,000 attributes or variables, then I have to have 1,000 setar methods to set the values for these variables, which is practically difficult. That's why we go for the next concept, which is constructors. So What are constructors? Constructor is a special method used only for initialization purpose. There are some rules. It is a special method and the main purpose of the constructor is to provide initial values. The name of the constructor and class must be saved. This is important. The name of the class and the constructor must be same. And then return type is not applicable for constructors. The next important concept is this executes automatically we are not required to call explicitly. And per object, only one time it will execute. So let's look at one example. So for example, let's say I have one method void m and I write a print statement here. So what I'll write is this is a general method with some actual business logic. So I'll call class A object new class A, and then I need to call the method M for the actual business logic. Let's try to, I have not included the constructor yet. Let's try to compile and execute. So the actual business logic method got executed. For example, I have a constructor. Like I said, it should be the same name as class. So A, and let me write a print statement. And I'm trying to mimic some initialization logic here. Constructor example, initialization code logic is implemented here. And this is going to execute first before the actual business logic, and no need call this constructor explicitly. So I just defined a constructor and I have not called here. Now let's rerun this program. Compile. Execute. So if you see here, this is the first logic that got executed, then the actual business logic got executed. And in the program, I have not called the constructor, so it will be called by default. You don't need to explicitly call it. So now let's move on. So how many types of constructors we have? We have three types of constructors available. So what is the first one? Which is default constructor. Second one is parameterized constructor. Or user-defined constructor. What is the third one? Third one is a copy constructor. Let's look at each of this with an example. First one is default constructor. So what is a default constructor? If we are not writing any constructor in a class, then compiler will automatically create a constructor such type of constructor is called as default constructor. Let's see a simple example. For example, if I have a class called B and I'll just remove everything and also remove everything from the main method. So let me just try to run this program. Compile. It's compiled. So if we want to see the profile of the Java program, we have a command called java p. And for example, I need to check the profile of B. So if you see here, this B constructor, which is a default constructor, I have not created it, but it's there by default. So compiler has created it. That's called a default constructor. And this is also applicable for any other class. So let me look at profile of test. So if you see, there is a constructor for test also, which is a default constructor. Now let's look at parameterized constructor. So the constructor which takes parameters is called a parameterized constructor. Let's see example. For example, class student. And inside student, I have int ID and string name and double percent and let me define a student constructor with parameters as we are looking at parameterized constructor int a string b and double c, and inside this constructor I'll assign int id is equal to a, name is equal to b, and percentage is equal to c. So it doesn't have any return type, so I have to write a method to show the student details. I'll use show method. And there is a system out line. System out int lm id plus I'll add a tab space plus name of the student plus another tab space plus percentage of that student. So now in our main method, I need to create student object. Say for example, one student S1 equal to new student, and parameters are one comma say John, the name of the student, and then percentage is 56.78. And I'll call S1 dot show. I'll do the same for student 2, S2, ID is going to be 2, and then name is Tom, percentage is 67, 7. ID is 3, Mike, 77, 27. Let me run this program, compile. I need to change that to S3. Compile. Execute. So what did I do here? I'm showing S1 everywhere. I need to show S2 and S3 here. Save, compile. execute. So I got all the student details printed to the console. This is called a parameterized constructor. Now let's move on to the last constructor, which is copy constructor. Copy constructor, it is used to copy the content of one object to another object. As simple as that. So let's see how this works. I'll create another copy constructor, which is student here, and then take the parameter as student temp, and then I need to define ID to temp dot ID, then name is equal to temp dot name, then percent is equal to temp dot percent. So here, let's say I have student S4 that's equal to new student, and I'll feed S3 into S4. And then let's show S4. Let's compile. Execute. So I got the fourth student details using a copy constructor. That's how a copy constructor works. I'll stop here, and this is the end of this session.